Okay, so the properties and logs of logarithms. So we talked about a little bit of the basics yesterday, transforming or going from exponential form to logarithmic form. And so today we're going to talk about the actual specific properties. So the basic properties of logarithms, that they're defined only when the domain is greater than 0. The graphs of them contain both the point 1, 0. So the log of 1 is equal to 0, and the natural log of 1 is equal to 0. And that should make sense because we're talking about exponents. Okay? And that 10 to the power of 0 is 1, and e to the power of 0 is 1. So that should make sense. That one of the basic ones here, that if we have the log of 10 to the power of k, it equals k. Natural log of e to the power of k, it equals k also. And that was, we actually did those problems that utilized that yesterday. And also that both of these things here are really talking about inverses, that here and here, that the common logarithm has a base of 10 and the natural log has a base of e. So both of these two things here show us the rules for inverses, because they, when they're inverses, they basically undo each other. So here's some of the basic properties here about logarithms. And so when we're solving problems, like number 1 says use the basic properties of logarithms to solve the equation log of x minus 3 equals 1. Now, we don't know how to do that using the logarithm, but we can change this to exponential and say that 10 to the first power is equal to x minus 3. And then this becomes a very easy equation to solve. But most of the time when you're looking at logarithmic equations, you can solve them easier by changing them to exponential. And a lot of times the exponential equations can be solved easier if they're in logarithmic form. So in this case, we just add 3, and x equals 13. Now, these properties or laws of logarithms we talked about in Algebra C. Here are the first ones are the product properties, which say that if I have the log of a product, it's equal to the sum of the log of each of those individual things. So the log of VW is equal to the log of V plus the log of W. The natural log of VW equals the natural log of V plus the natural log of W. Okay? And if you had 3 things multiplied, then you would do the log of all 3 of those things added together, or 4, or whatever. It doesn't matter how many of them you have. Now over here on the right, we have a caution that says a common error in applying the product law of logarithms is to write this false statement. Okay? And remember, it says the log of 7 plus log of 9. That means the log of 7 times 9, not the log of 7 plus 9. So make sure you don't make that mistake. All right, here it says use the product law of logarithms to evaluate each one. So they tell us that the log of 3 equals 0.4771. Log of 4, 0.6021. They want us to find the log of 12. Well, how can I use 3 and 4 to get 12? Okay, multiply them, right? So we can rewrite this as the log of 3 times 4, which is the same as the log of 3 plus the log of 4. Which then all we're going to do is take those two numbers and add them together. This equals 0.4771 plus 0.6021. Except it gives you the numbers here, so you could do this without a calculator. Okay. Same thing with natural log. Here for letter B, they want us to find the natural log of 18. So we could do the natural log of 3 times 6 to get the natural log of 18. And then we can add them, natural log of 3 plus the natural log of 6. So 1.0986 plus 1.7918. And then you just have to do that add. Okay. So the product property says if I have the log or natural log of a product, it's equal to the log or natural log of the sum of each of them. The quotient rule, quotient law, says that if we're dividing, if we have the log of a quotient, it's equal to the log of the numerator minus the log of the denominator. Okay. So the log of V over W is equal to log of V minus the log of W. Okay. Same thing applies when we're using natural log. And we have a caution for quotients also. So if I have the log of 40 and the log of 8, and I want to find the log of 5, I do the log of 40 divided by 8. So the log of 40 minus the log of 8. Okay, so we take those two numbers and subtract them. We've got the natural log of 32, natural log of 8, and we want to find the natural log of 4. Natural log of 32 divided by 8. So natural log of 32 minus the natural log of 8. So the product property says if we're multiplying, then we can add the two parts, the log of the two parts. Quotient law says if we're dividing, then we're going to subtract the log of the two parts. The log of the numerator minus the logarithm of the denominator. No, it didn't. Did I skip one? I did. Okay. All right. Power laws. All right. So if we have the log here of v to the power of k, I can take that exponent and I can move it to the front. Okay. So one problem that we did before with that is like if we had the log of 10 or the log of 1,000, okay, for instance. That would be the log of 10 times 10 times 10. So this would be the log of 10 plus the log of 10 plus the log of 10. So 3 log of 10. Well, log of 1,000 is the same as the log of 10 cubed. So it would have been easier just to take that exponent and move it to the front. Okay? We get the same answer, 3 log of 10 versus doing this. So the power rule says that I can take the exponent and I can move it to the front. Now it has to be the exponent of the whole thing, because if I have something that looks like this, what's the exponent for there? Okay, just the x. Is it for the 2? No, so in that case, I can't pull the 3 to the front. Okay, it would have to be, the whole thing has to be raised to that power for me to be able to do that. So number 4 here, letter A, we have the log of 25 to what power, Paul? Okay, to the 4th, to the 1/4 power. Okay. So I can take that 1/4 and move it to the front, and I can do 1/4 log of 25. Now these rules are important because we're going to be doing some simplifying, and when we're doing that simplifying, we're going to be utilizing all of those properties in doing that. So for letter B then, natural log square root of 22, 22 to the 1/2, so 1/2 natural log of 22. So we just need to multiply those numbers in A and B that they give us for the log of 25 and natural log of 22 by that number. Yes, sir? Whatever you need to do, Caleb. Is it okay? No. You mean put an NL instead of LN? No. Because that's not the right way to write it. Because they knew you were going to come along someday, Paul, and they just wanted to frustrate you. Okay, so here we have, for number 5, we have, they want us to simplify this logarithm. Okay, so they want us to write it as a single logarithm. Okay. So in this, we have plus signs and minus signs, numbers in front of logarithms and not. So the first thing we need to do is that to be able to simplify this to a single logarithm, we must have 1 log of each thing. So in other words, the coefficient of each logarithm must be the number 1. Okay? So anytime we have a coefficient of the logarithm, that needs to become an exponent first. So in this case, we have, for the middle one, we have 3 in front of the logarithm. So my first step is going to be to change that to an exponent. So we have the log of 8x plus the log of x cubed minus the log 2x squared. Now the other thing you should always do, and in this case we don't have to worry about it because it's already in that order, but whenever you have, when they're adding and subtracting, always make it so the order is so all the adding things come first and then the subtracting things. Okay? Because what happens is usually students will get those switched around, because adding means to multiply when we're talking about simplifying the logarithms, okay? And subtracting means to divide. And the thing is anytime there's an adding, that's always got to be multiply, which means it's going to go in the numerator. And anytime we're subtracting, that means we're dividing, it's got to go in the denominator. And so one way that would help would be is if you always make sure all of your adding comes before your subtracting in these. I know it's kind of different than order of operations, but you know, it should make a difference. All right, so now Anywhere we have a plus, we're going to multiply, and a minus we divide. So we have the log of 8x times x cubed, because those are added, so those are being multiplied together in the numerator. And since I have a minus log of 2x squared, that 2x squared is going to go in the denominator. Notice I only have one single logarithm now. What's that? Yep, and then we're going to simplify that fraction. So we can now simplify this fraction. Let's see, 8 divided by 2 is 4. And in the numerator, I have x to the 4th power. In the denominator, x squared. And when I simplify that, I get x squared. Okay. So this whole thing then actually just simplifies to that right there. Some days I'm really perfect. Thanks, Jim. Okay. All right, so there's those basic properties of logarithms: product, quotient, and the power property. Okay. And those will get you through the first section of what you have to do today.